So we continue. We are now doing question 2. The question 2 starts by saying, use Pascal's triangle to expand 3 minus y to the power 4. So question 2. A, part 1. So one to use Pascal's triangle to expand 3 minus y power 4. So you know, Pascal's triangle is this one. We want 4. So 4 we go to this line. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1. So these are the coefficients that are going to have to use. So now we're saying, okay, 3 minus y power 4 is going to be 3 to the power 4 plus 4, 3 power 3 minus y plus 6, 3 power 2 minus y power 2 plus 4, 3 power 1 minus y power 3 and plus minus y power 4. So that's how you get the solution there. So you could easily work out those numbers. So the numbers will be 81 plus 27 by 4 there, 108. So to be minus y, and then plus 9 times 6. Let me just say 9 by 6. It doesn't calculate the value there. And then plus minus. So y power 3. And then plus y power 4. And then part 2. So part 2, the question says, can you express express 11 choose 4 plus 13 choose 10, plus 13 over 10, 12 choose 9 plus 14 choose 5 in the form NR as a single binomial coefficient. Significant. So you may be asked to do such a thing whereby you are given the binomial coefficient that you can express in one form like that. The big deal. Let's see how we do it. So what are we expressing? We're expressing 13 plus 4 plus 13 over 10, 4 choose 9 plus 14 choose 5. So now we have 3 identities that we use. The first one is any error is the same thing as n minus r. This number is, these two numbers are equal. Then the other one says, okay, if you have any error plus n r minus 1, if you add these two, you get n plus 1 array. Those are identities. And the third one is if you have n r minus 1 plus 2 n r plus n r plus 1. When you add these, you get n plus 2 r plus 1. So out of these three identities, we can use the top two. But before that, we should work out this and write it as a binomial coefficient. So that is 13 over 10. Then we have 4 factorial over 9 factorial. And then 12 minus 9, that is 3 factorial. Okay. So that we can reduce 12 as 12 by 11 by 10 up to 9 factorial over 9 factorial by 3 factorial. So that this 9 factorial and this one can cancel. And then we have 13 over 10. And then, before we go to 13 over 10, also this 10 and that 10 can cancel. So now we remain with 13 times 4 times 11 over 3 factorial. Our target is to express this as a binomial coefficient of the form NR. So if you see 13, so you just pick this, the bigger number up here, minus the number down here. So now we write this as 13, 63. Because if we subtract, so if you just want to see if that's true, you would say 13 factorial over 3 factorial, and then 13 minus 3 is 10 factorial. So you can work out things, you have 13 by 4 by 11 by 10 factorial over 3 factorial by 10 factorial. It is in times. So you see that we have 13 by 12 by 11 over 3 factorial, which we have here. So you just get, after you're done simplifying like that, you get the bigger number 13, choose the number down. So now we go back and substitute there where there is 13 or plus. So if you look at here, we have 13, 3 now, 1 now. And then plus 14, 5. So now we use property number 2 to handle this thing. You see, there's 13 R. So n R plus n R minus 1. So 13 to 4, 13 plus 3. 3 is 4 minus 1. So we have 13 plus 1, which is 14, plus 4, and then plus 14 is 5. So this is like R, this is like R minus 1. So again, we'll use the same 14 plus 1, we get 15, and then plus 5. This is a single binomial. So you just need to know the not big kind of easy.
I'm a bit lost, sir.
Where are you?
Yeah, how you found 14 over 4. In fact, the whole thing that you put in the small box, that one. how you came up with the other one on the right side.
So we have this 13 plus 4 in this one. And then here we got 13 plus 3. And then 14 plus 5. Now this one, we brought it 3. So if I have 13 here and I have 4 here, I should have 13 here and 4 minus 1 will be 3. Also 3 will have them. So we can write it as n plus 1, so meaning 13 plus 1, choose 4. And 13 plus 1 is 14. That's why now we have 14 is 4 plus 14 is 5 here. Then again, if we come back here, n, so we have 14, 14. And then r, that's 5. The bigger one. Then 5 minus 1 is 4. That is our r minus 1. And then from here, we want to move to here. So our n, which is 14, we add the 1, it becomes 15. Then pick the r, which is 5. So we put it 5.
Kindly repeat.
So which part? Being recorded, don't worry. So one will say, can you repeat, where is that from? Which part is confusing the most? So we got that there.
I think on that box, 13 is 4 plus 13 is 3. That's why you should start from like, how are you coming up with 13 plus 4 plus 14 plus 5?
So the 14 plus 5, this one, is in the question. This is 14 plus 5. Because we are adding 3 things, this part, and that part. So this 13 plus 4. So just wrote down here. That 14 plus 5. So just wrote down here. This is the one that we calculated. We initially had 13 over 10, 4 to 9. 4 to 9, by definition, is 4 factorial, 9 factorial, then 12 minus 9 is 3 factorial. So we have simplified here. 4 factorial is 4 times 11 times 10 times 9 factorial. Because you are seeing a 9 factorial down, those can cancel. Okay, so if they cancel like that, then we remain with 12, 11, 10. 10 over 10. We remain with 13 times 12 times 11 over 3 factorial. The idea of doing this was so that we can write this as this. And that. So we try to find a way of figuring out what that could be. We said, okay, the easiest way would be, I pick the bigger number, 13, choose 3. Because it's obvious that the reason why there's only 3 down here, one number, which is supposed to be multiplied by 3, has been cancelled. By what? By a number up there, and the number which is missing up there is 10 factorial. So it means if we say 13 choose 3, it should make sense, because if I'm to bring back the missing numbers, I'll have a 10 factorial there, and a 10 factorial down here. Since 13 minus 3 is 10. So now I've verified that this is just 13 choose 3, which we get and put here. So now I want to add that number plus this number plus that number. So 13 plus 4 plus 13 plus 3 plus 14 plus 5. To add 13 plus 4 plus 13 plus 3, we have an identity here. If you let n to be 13, you put it here, you put it here. Down here, you have 4. 4 minus 1 is 3. And if we check, we have 3 here. So it means that I can add these two to get this one. To get the sum, you add the 1 to n and get r. So n is 13. When we add the 1 to 13, it becomes 14. Between 4 and 3, we get 4, which is 3 as our r. So we have 14 plus 4 plus 14 plus 5. So we have 14 plus 4 plus 14 plus 5. Again, we identify our n is 14. Our r is 5. R minus 1 is 4. So we have 14 plus 1 is 2. 4 and 5, we get 5 will be that. Using this identity, your job is to identify what n is and what r is. Then you add to n, you add the 1. And the r, you just write it down. That's it. Okay. So we go back to the question paper now and check what's there. So we have part B, part 1. Find the constant term in the expansion of x squared over 3 minus 3 over x to the power 9. So we want to find the constant term. The constant term is the term independent of x. It is the term independent of x. It's one that is called the constant term. Okay, so B part 1, we are given x squared over 3 minus 3 over x to the power 9. So whenever they mention a term, ours is to record the formula. N r a n minus r b r. So n in this case is 9. We don't know what r is. A is x squared over 3 to the power 9 minus r. B is minus 3 over x to the power r. Then from there now, since we are told the term, the constant term, it is a term independent of x. So we want to put the powers of x together. So we'll separate the x from anything else. So right here, we'll leave 1 over 3, the power 9 minus r. We'll leave minus 3, the power r. And have our x, it's squared. So the square, and then 9 minus r. And this x down, we'll write it as x to the power minus r. So we'll have 9r, then 1 over 3, 9 minus r, minus 3, r. Then now the x, we add the powers. So we have 18 minus 2r minus r. You multiply 2 times 9 to get 18, 2 times r to get 2r, and then minus r because we are adding the powers of x. So now to find the term independent of x, which is a constant term, you equate the power of x to 0. So the power of x is going to be that. So R is equal to 6. Then you come back and say, oh, so the term 6 plus 1 is equal to 9, 6. 1 over 3 to the power 9 minus 6. Minus 3 to the power 6. Which is 9 to 6. To the power 1 over 3. Power 3. And negative power 6 is just positive. So we have 3 power 6. So the 1 over 3 is coming from x squared over 3. That thing can be written as 1 over 3 times x squared. We just wanted to separate the 3 from x squared, but because it's in the denominator, we cannot just put it like this. So we put a 1 up there and then separate the x squared along. Okay. So now this means that this can be written as 9, 6 to the power 3 power 3, which is 9, 6 multiplied by 47. So you guys can find the value of 9 to 6 and multiply by 47. Where has the 1 over 3 gone now? Because it's the same thing as 1 over 3 power 3 becomes 3 power 6. So the same base, you can write like that, which is 3 power. Okay. Am I fast? So when calculating the numbers like 18 minus 2r minus r, 18 minus 3r equal to 0 and get it there I'm fast. Because what I want you to learn is that what is important here is to have this formula.
Hi, sir.
Hello. Because I know if you have the formula, then the next thing is you substitute. So substituting there you must be very fast. Just check, oh, n is 9. So you put 9 r, then x squared over 3, that's your a, 9 minus r. Then your b is minus 3 over x, the power r. From there again, you are removing everything from x. So you leave 1 over 3 alone, the power 9 minus r. You leave minus 3 alone to the power r, and then x squared to the power 9 minus r, then x to the power minus r. Realizing that I'm looking for a constant, so I put the powers of x together, like that. And then I equate to 0. Quickly, I come back and substitute this r. I'm now coming in the 6. And from there, you simplify things. You get that. What was the solution for the exercise I gave you? The first one, the table has numbers like this, isn't it? I think we had -4 and -2, the first one. Then we found something like this. That was it. That's what it was. So we found the minus here, and the 5. So when I change the question, I put greater or equal to 0. It means that your solution set was going to be -4 to -2. Like that. So just no solving. This was the same question, just change the inquiry. You just come and get the flat part. Then the other one was 2x minus 3. That's equal to 5. That's equal to -5. So you get -2. That's equal to 2x. That's equal to 8. So you're supposed to get -1. That's equal to x. That's equal to 4. So your first this is binomial. You want to doing here. Okay, let's go to B part 2. Let's go back to the question. So without expanding, for what values of x is the expansion of these in ascending powers of x value? So we are here to find the range of ideas. We don't have to expand anything. We just need to find where it would be valid when we expand it, or if you were to expand it. So let's see how we get it. So, how do we get it? So we have, that was B part 2. Two minus x plus 1 over 3 plus x. So what you do is you can write this as 2 minus x to the power half plus 3 plus x power minus 1. Hello.
This is supposed to be 3 minus 8.
Supposed to be 3 plus x.
Inside the root.
Inside the root, supposed to be 2 minus x. So you pick this minus x to be less than 2 and x to be less than 3 from here. So you always pick the x part in the absolute to be less than the a part. Also the x part in the absolute to be less than the a part. So that here we'll have the absolute value of x less than 2. Here we'll have the absolute value of x less than 3. But look, this means that we have -2 less than x less than 2. Here we have -3 less than x less than 3. If you go on a number like you have -2 to 2. You also have -3 to 3. Now, since those two are being added to give us one thing, they must all be defined at the same time. So you get the intersection set. So you say range of variables is equal to -2 equals to 2. Like that. So I hope you guys managed to get the screenshot of those questions of using it so that you can solve in your own time, because now this could be the boundary for this lesson in terms of so tomorrow we'll still have a class. So for the sake of people who are having classes in different times, tomorrow in the morning, right? You just need to agree in the morning, like we can start at 6. I know if you start at 6, some people have questions at 7, don't agree. We start at 5. We end at 7. But no one is late for class. For those who have a class at 7, don't worry, we'll end area. We'll end at 6. We end at 6:45 or 6:40.
Yes, sir, that's a great time.
Yeah, so do 5 to 6. So the link, the same link, guys. So use the same link. So there's nothing to extend the link towards. Just know that even if you are sleeping, the class will be there at 5. So then, oh no, this is the AM like before the sun comes out. Yeah. No, by 11:20. By 11:20. Your test is on 15th. So we'll deal with all your questions. Just we concentrate on them and
Thank you very much, sir. More time.
The time, sir, because some of us were not in school, we just come from home, so
So like,
and we're having classes.
so like that can see we are doing 11:20. Maybe you can just say it's fine, you can say. You want to 11 break up. Then they cannot take that's
I know
So
what
I think for those that won't manage to attend, we can just send them the recorded class.
Mm.
Okay, bye-bye.